Good morning. Welcome to day 2. My name is Jill Payne, and I'm a Sloan Fellow MBA student at the MIT Sloan School of Management. It's my pleasure today to welcome you to our workshop series at the 2019 Sloan Sports Analytics Conference presented by Rakuten. It's my pleasure to introduce Andy Brady, who's Director of Analytics for Rakuten's Intelligence Group. And I'm happy to present his talk today, SQL for Data Analysis, Measuring Customer Loyalty and Value. So please help me in welcoming Andy.
Thanks, Jill. Thanks everyone for being here. 9 a.m. snowing. It's a pretty wild turnout, so appreciate you all coming out. As Jill mentioned, I'm Andy. I work for Rakuten Intelligence. For those of you who don't know what Rakuten is, it's a Japanese company. Kind of think of them as akin to Japan's version of maybe Amazon. And you might have noticed them kind of in the sports market a little bit recently as the jersey sponsor for Barcelona FC and the logo patch on the Warriors NBA jersey. A little bit about, I guess, the Rakuten Intelligence Group. We're a market research division of Rakuten. We actually focus on e-commerce research, and we have a data set that is made up of billions of rows of e-commerce purchase data. It's data we collect from 6 million members through their email inboxes, and we aggregate that data, do research on it, and actually work with clients to kind of better understand the shopping behaviors and trends that are going on in e-commerce. So what we're actually going to do today in this workshop is take one of those, a data set that we have for a couple of different merchants. So if you do have your laptops here, some links will come up on the screen in a second, but you'll have the opportunity to download that data set, download an editor, and actually query along as we kind of learn some SQL and you know, how we can actually start to analyze some of this data. So those are the links if you do want to download it. They'll be up over the next few slides, so you know, take your time. But basically, what we're going to learn today is firstly, what is SQL and why should we learn it? A bit of the structure of databases in general and the kind of tools that you'll use to query data. Then how we want to structure those queries. And finally dive into actually using some of the stuff that we've learned to calculate some actual metrics on the data set itself. So first things first, you know, what is SQL and why should you learn it? SQL or SQL stands for Structured Query Language. The most important thing you need to decide is how you pronounce it. It's really up to you. It's kind of one of these GIF versus GIF you know, debates, but I'm going to call it SQL, so you know, feel free to use whichever one works for you. In terms of what it's used for, it's basically the default language for querying databases. So, you know, as you can kind of tell from structured query language, it's really exactly what it is. It really kind of explains exactly what you'll do with it. And then I guess why learn it, right? So I guess hands up, who's used SQL before? Okay, so great amount of people. For those of you that haven't, I think there's really 3 main reasons why you should learn SQL. So the first thing is you can use it about anywhere. And what I mean by that is any database that you come across, and every business has one, you know, regardless of whether you know, you might be working somewhere where everything lives in Excel spreadsheets. In a sense, that's still a database. So every business has one, and if you know SQL, you'll be able to really interact with pretty much any database anywhere that you're working. Second point is it has longevity, right? So you know, especially in analytics and data science, you know, a lot of languages kind of come and go. You know, maybe if you ask people 15 years ago, they would have been using MATLAB. You know, 5 years ago, they would have been using R. Now everyone's using Python. But underlying all of that is, you know, SQL is one of those constant languages that, you know, 10 years ago, 5 years ago, 15 years ago, it's kind of, you know, it's a constant of a skill that you need to have. It's been around from the early 70s, so, you know, really kind of explains how long and how useful it has become. And the third point, and I think this is the most important, is it actually makes you seem better than you are at your job, you know. I'm sure everybody's run across that person who's like, really great at Excel. They might be able, an Excel wizard. They can use all the pivot tables and indexes and VLOOKUPs that, really complicated things. All that and way more you can do much more easily using SQL. So it really allows you to kind of upskill and really perform well and efficiently in your role. So I guess a little bit about databases. What we're going to talk about is a relational database. By and large, this is the most common type of database that you'll come across. But essentially, all a database is a collection of tables, right? And in a relational database, those tables each relate to one another in some way. So this is actually the two tables that we will be using today. So we'll have our transactions table and we'll have our merchants table. We can link those tables based on merchant ID. So you can kind of see that there's a common ID in both of those tables. That'll allow us to link them together. It means that we can actually get more information from one area and append it to another area. In terms of what a database table is, again, kind of akin to Excel a little bit. I would think of this similar to an Excel spreadsheet. It's a collection of columns and rows, but in this case, the columns we call fields, the rows we call records. All right. So the tools we can use. In terms of SQL, there's a lot of different types or flavors of SQL that are out there, and it really depends on the database that you're using. Some of the more popular ones are, MySQL is a very popular one. Postgres, if anybody's used Amazon Redshift, that's a slight take on Postgres. But really, once you kind of know one version of SQL, you kind of can know them all, because you'll have to make slight tweaks to your code, but in general, the same structure always holds. There might be some slight variations in different functions you can use, but by and large, you can transfer it from one database to another. So in this workshop, we're actually going to use a SQLite database. SQLite's a little bit different than other database options because it's actually a local database, so it lives on your local machine. Most databases live on a server. That allows people to connect to them remotely. I can connect, you can connect. If I make a change, you guys will all see it. In a local database, you're not going to see that. It's going to live on your machine. Anything you do is localized to you. A lot of applications and apps and programs kind of use SQLite databases. A good example is Chrome. All of your history stored in a SQLite database that's actually on your computer. So what we're going to use is a SQLite database file and a GUI called PopSQL. They're very clever with their name. So if you haven't downloaded them and you do want to follow along, I would ask that you kind of download them now. So first thing we need to do is actually connect to our database, right? So we're going to do this in PopSQL. Now, I might switch out of this. So it should be this little, well, no. All right. So this is what PopSQL looks like. Has everybody who wants to follow along got it up on their screen? Yeah, by and large? Okay, cool. So first thing we need to do is create a connection. We can do that at the top here in the connection bar. So we'll click on that and go to Manage Connections. And it'll bring up this box. What we can do is create a new connection. So in this case, we'll create one here. We want to select the type. So we're going to go down to SQLite. Click on that. You can call it whatever you like. In my case, I've called it Sloan Sales Data. And then you can actually browse to the file. So go in here, select your file. So I'll give you just a little bit of time to connect to that. While you're doing that, though, we can just kind of have a chat a little bit about some of the basics of the GUI here. So once we're connected to our database, we can have our query window. We can also have our schemas window. So the schema is actually where the tables will live in this database. So we can actually see here that we do have our two tables. So we've got our merchants table here, we've got our transactions table here, and we can actually see the different fields within each. So in our merchant table, we've got ID and merchant name. In our transactions table, we've got some information about the item, so the ID of the item, the description, that kind of thing. So let's actually talk about queries themselves and what we're going to learn, how you should structure them. So basically, there's 6 main parts to a query. Now, you don't always use all of these 6 parts, but in a combination, some of these things will always be there. We're specifically going to talk about querying data, so not worrying about how to update things, how to delete things, that kind of thing. We're looking at it purely from a selection of data. So that's where the select statement comes in. I would say in probably 95% of queries that you will ever use are going to start with a select statement. Select statement kind of tells you what it does. You actually tell it what you want to select from the database. So you can specify the fields that you want, or there's the shortcut of the asterisk or star, and that'll actually return every field in the underlying tables that you're selecting from. So that's a nice shortcut to get you everything. Then there's the from clause. So basically this is telling it where do we want to get that data from. So we can select one table, or in our case, we'll probably want to select from both tables. So we can do that by using a join clause to select from multiple tables. We'll cover that a little bit later. The where clause, this is really how you should filter the data set. So it doesn't really make sense to return everything in a data set. You can't do a lot with that. Basically, you're just looking at raw data. So the where clause really allows you to filter down to just the things you need. The group by clause. So this is actually where we'll start to get into being able to kind of do some calculations. Group by is basically a way to group different rows of data into a group and perform calculations on that group of data itself. Then there's the having clause. We'll touch on this a little bit, but it's similar to the where clause. It's really used for groups, and it's a way for you to actually filter your groups later down. And then there's the order by clause. Order, basically tell it what, how you want the data sorted when you do get to the end. So first thing we're going to talk about is selecting data. So we'll start with the simplest possible query, which in this case is select star from transactions. So this will actually, if we run this, allow us to have a look at the transaction level data. What does it look like? We can start to kind of see what we've got in there. It's not that interesting, but it'll at least give you an idea around what's in the data set. So again, let's go on over to PopSQL. So if we run this, it's going to query the data. So we can see it's querying there. And once it's done, it's going to return our rows of data. Right, so we can see query's a success. We've got 782,000-ish rows of data in here. If we have a look at what those are, we can see that there's an item ID. So this is a transaction level database. When we say transaction, what we're talking about is within an order that we see, you can buy multiple items. Each one of those items is going to have a unique ID. And then some other information about it. So we've got the description of what the item is. We've got the price of what the item is, the quantity, whether it was part of, what order it was part of, when it was ordered, which merchant it was bought from, and who bought it. So from here we can see, at least we can kind of see, we've got some interesting info here, but what if we actually want to know, okay, we've got merchant here, but everything, at least on this screen, is merchant ID 2. So what merchants are actually in here? So we can kind of take our query And the next thing we can do is winnow that down a little bit. So what we're going to do is a slight variation. This one's going to be select merchant ID from transaction. So now instead of returning all of those rows, we're going to actually specify that we only want the merchant column. Again, 782,000-ish rows. Again, we get all twos back at the start here. So again, not really informative. So we actually need to use a slightly different operator, and that's the distinct operator here. So what this is going to do is only return distinct rows of data. So get rid of all those duplicates and actually tell us, okay, what are the merchant IDs we have in this table? So if we were to run that, hey, great, we get back 3 IDs. So we can see that we've got merchant 2, merchant 5, and merchant 4 in this data set. So that's kind of the basic, at its basic form, how you would select data. We'll run through that. Next is then, I guess, how we would filter the data. So when you're filtering data, basically you're checking a condition that you want to match. So in this case, we've got a bunch of different comparison operators we can do on that. We can see if things equal one another. So if merchant ID equals 5, as an example, we can look at if something is not equal to, if we want to match everything that's not merchant 5, for instance. Greater than, less than, between, in. So there's a whole bunch of different operators that we can actually use to test conditions. But then there's also logical operators, because quite often it's more than one condition you want to put in a query. It's great to look at merchant ID equals 5 as the example we're going to use. But what if we only want to look at sales that were in January? So what we can start to do is use and or not to actually chain these together. And it's similar to, you can kind of think about it similar to a bit of a math equation, because if you put things in parentheses, then that gets run before the next operator. So you can actually start to chain these together, similar that kind of would in a function if you were doing a math equation. So for our example, what we want to find here is everything that's in the transaction table where the merchant equals 5, the price of the item is greater than $10, and it was ordered between January 1st, 2018 and January 31st, 2018. So if we were to run that, we're going to get a result, and we've winnowed it down to 14,000 and a half rows. So we're actually starting to winnow the data down now. And this is where we can start to do some actual interesting things with it. And how we're going to do that is through aggregates. So aggregating the data is basically you're performing a function on a group of that data to calculate over that set of values and come back with one number per group. So there's a few different things you can do. You can average things, you can count things, you can look for minimum values, maximum values, and you can sum the set of a set of values. So for us, since this is a e-commerce, it's a sales data set, the most obvious one seems to be, let's calculate revenue, right? So what we're going to do is calculate revenue. In this case, revenue equals price times quantity, both fields we have in our data set. So the first thing we would be able to do is actually calculate it for each individual item in the data set. The way we would do that is select item ID, then price multiplied by quantity as revenue. Now that as revenue is what's known as an alias. So it's basically just telling SQL that we actually want to name this new calculation or this field that we've done, we want to rename it to revenue. One thing to note, that only exists in your query. If you go back to the underlying table, it won't have added a column called revenue or anything like that. It's just going to exist in your query itself. So that's great. What that'll give us is, again, our whole data set. It's going to show us the item ID and the revenue. So if we were to jump back in, we're going to come back again with a big long list of item ID and revenue. So item 1, $170, item 2, $180, etc. Now, that in itself, again, not that interesting. We've done it at the transaction level, but there's no way for this to actually tell us anything. So next thing we're going to do is let's sum that revenue up. So the first one we're going to look at is sum of the total revenue. So what this is going to tell us is within the data set itself, as a whole, how much revenue are we seeing? So in this case, we're seeing, what have we got? $67 million-ish in revenue. But again, that's the total. Good to know. That's the size of our market in this case. For our 3 merchants is 67 million. But again, what if we want to look at, say, an order trend? Now this makes much more sense. You want to look at sales over time. So what we're going to do here is group by order date. So now we're going to select order date, do the sum for our revenue calculation, and we're going to group it by that order date. And what that's going to tell us is a much more interesting story about what do sales look like over time. Now, this will return a list. Again, each day, that's the revenue for the day. We probably want to look at this visually. So you've got a few options. Obviously you could export it, put it into Excel. One of the good features in Pop SQL is you can actually do the exploration within the editor itself. So if we click Explore here and click on Chart, now we can actually see over time what that revenue looks like. So we've got some pretty interesting spikes. So over here we have December 8th, 2018. Don't know what happened that day. That's a pretty random date. We can kind of see down here November 26th and November 23rd. That makes much more sense. That is Black Friday, Cyber Monday. The biggest, at least in e-commerce, shopping days of the year. We've also got some other pretty interesting spikes. So now we can see we've got another one in September. So something's definitely interesting going on in this data set. And we're going to dig into that in a second. So, all right. So what if we actually wanted to look at a slightly different view of this? Let's say we only care about days that are, have over $100,000 worth of sales. Now, this is where the having clause comes in. So we have a look at our next query. We're actually going to run the exact same query as above, but what we're going to add is that having clause. So here we're going to specify that if sum of price times quantity is greater than or equal to 100,000, that's what we want to get. We can't put this in the where clause because in the where clause we're testing against the fields that are already in the data set. The having clause actually is where you can test against things that you're calculating. So it's slightly different, but it acts in the same way that a where clause was. Same, you can have multiple operators within that having clause. You can chain them with ands, that kind of thing. So if we were to run that, what we're going to get back is 333 rows. So this data set itself is 25 months, December 2017 through December 2018. So out of the 396 rows or dates we have in there, 333 of those days we're actually seeing more than $100,000 worth of sales. So that's good. At an aggregate level, between the 3 merchants, we can kind of see. One thing we still don't know though is what are those merchants? So this is where we can start to join our tables, get some more context really around what's going on in the data set itself. So the way we're going to do that is actually by joining the 2 tables. So the join clause basically, in essence, it just allows you to take one table, take another table, and tell it how you want to link it. The way that you can do that is using the on operator to choose and kind of identify that common field. So in this case, what we want to do is replace merchant ID, which is, unless you happen to remember who merchant 5 is, isn't really that descriptive, and replace it with merchant name from the merchants table. So our query for that is going to be select t.star. So in this case, again, we're going to start using aliases. The reason we're going to start using aliases here is we want to give our table names aliases because now that we have common fields in both tables, if we try and say select merchant ID, it doesn't know which table to select from. It's going to throw an error at you. What you have to do is actually specify the table before the field. Now, if you want, you can type out every time transactions.star, transactions.merchant ID. I choose to shorten that. So in this case, transactions is going to become T and merchants is going to become M. And then in our on clause, we can see that we're actually joining that on t.merchantID is equal to m.merchantID. So similar to kind of a VLOOKUP in Excel, basically, for this merchant ID, look in this table and return a different value for me. So if we were to run that, we're going to now get all of our transactions with a merchant attached. So again, we'll return, our 700,000 rows of data. And once it comes up, if we scroll to the very right here, we can see, we've still got the same fields that we had in our original T table. The reason being we selected T star, so everything from T. And then we can see we've actually got the merchant name on the end here. So the three merchants we have in our data set are all kind of sports apparel merchants. We're going to look at Nike, we're going to look at Adidas, and we're going to look at Lululemon. So the next logical step is let's look at revenue by merchant. Let's see how their trends are going over time. So first thing we're going to do is aggregate by month, because while it's interesting to look at things by day, you get a lot of noise. You'll start to kind of get lost a little bit and kind of chasing some false trends. So we're going to aggregate it by month so we can really see just a more simple kind of trend over time. The way we do that is by converting our order date into month. Now, this is one of those functions where depending on the flavor of SQL that you're using, it's a different function every time. SQLite, unfortunately, does not make it that easy to convert dates. So we actually have to use a weird little function here called strf time, which I believe stands for string from time. And we have to tell it that we want year, which is what this percentage sign y, and month being percentage sign m. And we're going to go 0, 1 so that we get the first day of that month. So we're doing a little bit of a conversion there. That's what we're going to call our order month. We're going to select our merchant name from the M or merchants table, and then we're going to do our revenue calculation. So again, we're doing the join and we're grouping. You'll notice in the group by clause here though, I've actually said 1 and 2. Again, it's just a little shorthand or that you can do in a query that says, hey, I want to group by the first field that I'm returning and the second field. So rather than having to type it out by name, I can actually just get there a little bit quicker. All right, so what does that look like? We'll run this. Okay, so again, we can have a look at our list, but it'll be much more interesting if we chart it out and have a look at it that way. Okay, cool. So we can actually see the trends now. You'll notice that Nike, which is red, and Lululemon, which is orange, have a pretty similar trend. One's higher than the other, but in general, they both kind of, are going in the same direction, have pretty similar peaks and troughs. What's pretty interesting though is Adidas's trend. So, December and September, which oddly enough aligns with those funny little daily peaks we saw earlier. Something's clearly going on with Adidas then. Any theories what might be happening? No? So, oh yep. Nailed it. So let's check into that. That's it. There you go. So what we can actually do then is dig into Adidas itself and look at the description of all the items that were sold. In this case, we're just going to look at September, but let's dig into it and actually see. So we're going to select item description. We're going to look at revenue based on the item description. In our where clause, we're going to specify that it's Adidas. We're going to specify that we only want things from September. And in this case, we're going to order by 2 being revenue, descending because we want to look at the top items first. So if we were to run that, we're going to get back a big list of items. So just as you thought, it's all Yeezy, you know. So the Yeezy Boost 350 and 700, you know, that's what's driving those increases. So, you know, we've actually, you know, now been able to answer, you know, a question about, you know, why are we seeing that in the data? All right, so the next thing we're going to do is actually start to extend our calculation. So one thing we can look at is, you know, what if we contextually we can look at the chart, kind of get a sense of how big things are. Let's actually quantify, you know, what the share is for these different merchants. So for us, our share calculation is going to be, you know, we're just going to look at December 2018. Our calculation is going to be, you know, what were the merchant sales in December 2018? And divide that by the total sales of December 2018. And the way that we're going to do that is first, let's calculate it for the merchant, let's calculate it for the market as a whole, and then let's combine the two queries. So merchant sales, you know, pretty simple. You know, we've done this query already. You know, so merchant name, revenue, you know, specifying the order date that we want to look at, and then we can do the exact same thing. Just get rid of the merchant name. So we're no longer creating that group. So this is great. We have our two numbers, but how do we combine them? Now we could export it. Again, we could put it in Excel. You can get out your phone and use the calculator, but we can actually do that all in SQL instead. So how do we combine them? What we're going to use is something called a subquery. And what this allows you to do is take one query, run it, and then run another query on top of it. So for this, we are going to get our two queries. So here's our query of total sales, right? So we've got our exactly the same code that we just used. But what we're doing now is we're actually using it within our first query. So we've got our merchant name, we've got our revenue. Now we're calculating revenue again. So this is again sum of price times quantity divided by our subquery. So what this is going to do is for every group that we have, it's going to take the merchant, calculate the revenue for that merchant, but then run that subquery and calculate the revenue for the total market and give you back a percentage. So if we were to run this, in this case, we're going to get back a result set where we can actually start to see the share. So, you know, for at least December 2018, we can see that Nike is controlling, you know, about 48% of the market. So that's interesting to know. But the other thing we can do is actually start to look at, you know, who's growing the fastest then. It's great that Nike, you know, owns 48% of the market in December, but, you know, what is that in context? Are they growing? You know, is based on what we're seeing from Adidas, you know, are they growing? You know, the trends make it look like in December, you know, well, they're going through the roof with those shoe drops. But, you know, let's actually look. You know, what does it look like? What we're going to do though, and this is the reason the data set is 25 months. We want to compare like-for-like periods. The reason being that we want to try and remove as much seasonality as we can. So, you know, comparing November to December doesn't make sense because, you know, by and large for any, you know, retail data set, you're going to see a decrease from November to December because November is, you know, the biggest shopping month online. So what we're going to do is compare December 2018 to December 2017 and just kind of benchmark how these merchants are growing year on year. So the way we can do that is, again, we're going to take two queries. We're going to take our 2017 query, so generate revenue by merchant for 2017, and then we're going to do the exact same thing, but in this case, do 2018. And again, we're going to have to combine these in some way. So once again, we can combine them using a subquery. So this one's slightly different though. In the last instance, we put that subquery as part of a field. Now what we're going to do in this case is actually join to our subquery. So think of it as kind of creating like a pseudo table. So we're going to get both of those queries, kind of create tables out of them, and then generate growth off that. So the way we do that is we can take our first query. So in this case, it is the December 17 query. We're going to put that in the from clause, put it in parentheses, and we're going to alias it. In this case, we're going to call it D17 for December 2017, and then we're going to join it onto the second subquery, being our December 2018 data set. So we're doing the exact same thing that we did last time, but we're going to alias it that way. Now we have to join them on something. Now in this case, we know that our common field is merchant name, so that's going to be our join operator. And then up the top here, what we can actually do is start to specify what we want. So our calculation for growth is going to be by merchant name. In this case, you could use D17 or D18. It doesn't really matter. It's going to give you the same result since that's our join operator. But then we want to look at revenue in 2018 divided by revenue in 2017, and then we're going to minus 1 so that we can get it down to the actual point growth or decline if sales went down. And what we actually end up with is a pretty interesting result. So despite the fact that Adidas had that shoe release, clearly they, we could go back and confirm this, but would have had a shoe release last year. Last year's shoe release was bigger than this year's. Nike, on the other hand, has grown 58%, year-on-year revenue, which is pretty impressive. In general, in e-commerce, we see as a market maybe a 30% growth. So the fact that they're at 58% is pretty good year-on-year. So next question is obviously, well, what drove that? So there's a few factors that could drive that growth, right? So we know that we're increasing revenue. The ways that you could do that is there's more people buying your product. So more people are coming in this year than bought last year. More orders being placed. Now that could be a side effect of more people coming in, but it could also be a side effect of people buying more. So existing people might be buying more often. This year maybe I've bought 2 pairs of Air Force Ones rather than 1. And people could just be spending more. Once they're really, have a real affinity for the brand, maybe they're moving more of their spend that they might have shared around between other merchants actually into Nike. Or it could be a combination of all of the above, and in 99% of cases, it's a combination. So what we're going to do is kind of extend the previous query that we had to actually start to answer some of those questions. So let's dig in a little bit further, and we'll talk about this query a little bit more in depth. So we're taking that same concept that we previously did for revenue, but in this case, we're going to extend it slightly and also calculate the number of orders that were placed, as well as the number of buyers that bought in both of those periods. And then we're going to use those to generate those summary statistics that we just spoke about. So the first thing is to update our 2017 query. So in this case now, we've got revenue, we need to add the orders and buyers. Now, we know that by nature, an order can have more than one item. So, we're going to reuse that distinct operator that we talked about at the very start. And what we're going to do is count the number of distinct orders in the data set. So the way we do that, pretty straightforward, count, and then within the parentheses of the count function, distinct order ID. Now, one thing you'll notice here is that I've had to cast that as a real number. The reason being, again, one of the quirks you will find in SQL is every field can have a different data type. In this case, order ID is an integer. In SQLite, if you divide an integer by an integer, it's going to give you an integer result. So the fact that we want to look at share, if we divide 10 by 3, it's going to give us back 3 rather than 3.33. So what we're doing in this case is actually casting it as a real number. So think of that as like a floating point number that allows decimals. So we're going to do that, and we're going to do the exact same thing for buyers. So we've done that. We're going to do the same thing for 2018, add in those exact same 2 extra components. And then up the top here, we're going to calculate our stats. So we've already done revenue growth. We did that in last. We're going to take that exact same approach to buyer growth, that same approach to order growth. And then we're going to also calculate orders per buyer and spend per buyer. So the way we're just going to do that, orders per buyer, we'll take the sum of all the orders, we'll take the sum of all the buyers, and then basically give us our how many orders is an average person making. And then we're going to do the same for spend. So take our revenue in total, divide it by our revenue, divide it by our total number of buyers, and see on average what does a person spend. Again, with calculations like these, you just need to be cognizant of making sure it's being done in the right order. So we can see, again, similar to kind of any equation, we want to make sure that we put those parentheses in the right place, that we're calculating it actually in the order that we want it to happen. So ultimately, what does that give us? If we were to run that, we're going to get a table back that looks like this, and it's going to tell us some interesting things. So we've already seen our 58% growth in revenue, but now we can actually start to see what's driving that. So if we look at buyer growth, buyers are up 38%. That's pretty good. Increasing your buyer base 38%. I think most companies would be happy with that. But that still doesn't explain the full 58%. So then we can kind of have a look at orders. Orders, on the other hand, they're up 48%. So makes sense. More people buying, more orders. But the fact that orders are up more than buyers, suggests that something else is also going on here. If we look at orders per buyer, it's 5%. Nothing huge, not a huge change there. But the real change is if we look at spend per buyer. So now people are actually spending 14% more at Nike than they were in December 2017. So that's a pretty interesting stat, because now we can kind of understand, okay, while Nike's acquiring more buyers, they're actually spending more with them, which we can kind of take as a sign of a healthy business. So then what if we want to kind of try and quantify these buyers themselves and answer a question like who has the most valuable buyer, right? So value you can kind of talk about in a number of different ways. Who has an idea around how you would value a buyer? Anyone? So we've actually already calculated this, right? So what we're going to do is look at spend per buyer. Really, how valuable is a buyer? Well, it depends how much they spend with you. So the way we're going to do this is slightly different, though. So in the past we were just looking at December. What we're going to look at is by year, how much is a normal buyer spending at each of these brands. So that way, again, we can take the whole year, we can take out that seasonality effect, because theoretically a buyer in November or December, around the holidays, is potentially spending more than a buyer in general. Somebody buying in March is probably not spending as much. So we're going to take that time frame, calculate it for all of these merchants, and just try and look at who really has these buyers. So again, it's taking queries that we've previously looked at, tweaking them slightly. So in this case, we're going to keep our spend per buyer calculation from the previous query. We're going to look at merchant name, but in this case, we're going to restrict it on the entire time period of 2018. So if we were to run that, okay, so we actually see something pretty interesting here. we're ordering it by most valuable to least valuable, I guess, in terms of spend, but Nike's actually the lowest. Adidas and Lululemon, surprisingly very close, but interesting to see that despite the fact that Nike is growing the fastest and has the highest market share, if we were to I guess, try and quantify value in this way, they don't actually have the most valuable buyer. If we're looking at buyer behavior, the other thing we can try and answer is, who has the most loyal buyers? So again, loyalty can be measured in a variety of different ways. Every company has their own metric for how they do this. Internally, if you were working for, say, Nike, your idea of a loyal buyer might be somebody who spends a certain amount of money, buys over a variety of categories, and orders with you more than twice a year. So it's kind of up to you how you would define this. But when we're looking across different merchants, one of the things we like to look at is the actual behavior itself. So what we tend to look at is something we call share of wallet. And basically what that's telling you is, okay, where are people actually spending their money? If we were to take a cohort of buyers, so in this case, let's talk about Nike buyers, across these three merchants, which in this case is our category, but in that market, where are they spending their dollars? So there's a few different components we need to do to actually look at this. So first we need to find all the buyers who actually bought from Nike, right? And that's going to be our cohort. So we no longer care about those people that only bought Adidas or only bought Lululemon, because when we're talking about loyalty to Nike, well, they have none. So we don't really need to look at that. So the second thing we're going to do is look at the spend of those buyers. So not only what do they spend at Nike, but what are they spending elsewhere? And then putting those together, we're going to divide the spend of those buyers at each of the individual merchants by their spend in total. So what that's going to tell us is, for the average Nike buyer, how much of their spend is going to Nike and how much of their spend is going elsewhere. So as an example, let's say that a Nike buyer is spending $80 at Nike. And then they also go on and spend $20 at Adidas. Our calculation in that case would become 80 divided by 80 plus 20, so Nike's wallet share in this case becomes 80%. So this is definitely the most complex query that we're going to run in this workshop. And it contains a few different parts and a slight tweak on that kind of sub-query that we kind of did earlier. So the first thing you'll notice is we need to calculate those Nike buyers. So how are we going to do that? In this case, we want to look at the distinct buyer ID. Right? We want to look at the distinct buyer ID because we only care about each person once. So we're going to select buyer IDs from transactions where merchant is Nike. So everybody who bought from Nike, we're going to return their buyer ID. We're putting that in a subquery. Now, what we're going to do then is, okay, that's our set. How do we include that? And that's where we can use the in operator. So basically what that does is tells us that we want a buyer ID within that set. So our query now is we're looking at merchant, we're looking at revenue from our transactions table, but the buyer ID has to be in that subquery. So you can kind of think of it as an in operator lets you give it a big long list of conditions that it can match any one of those and return you the result. So that's great. Now we have by merchant name, what's the revenue for these Nike buyers. But what do we need to do with that? And that's where our select comes in here. And let's talk about that top block for one more second. Now, you can see this is a syntax we haven't used before. In this case, we're saying with sales as, and then our subquery. Now, this is what's called a common table expression. It's basically a way of kind of creating what I would call a temporary table. Is probably the easiest way to describe it. So we're creating a temporary table, in this case called sales, that we can then actually just refer to in queries as if it was any other table in our database. Now, it's only going to persist while our query is running. So if you were to write this query, finish it off, and then in another query try and reference sales, it'd come back and say, sales doesn't exist, don't know what you're looking for. So it just kind of lives within our query session. So what that allows us to do though is reduce the number of times we need to create this data set, because when we talk about dividing by, for each merchant taking their spend and then dividing it by the spend of the total, we would actually have to generate the spend for each merchant, which would involve us getting all those Nike buyers. Then we'd have to do the same thing for all merchants combined to get all those Nike buyers. So it actually becomes a big, long query that if you need to make changes in, you'd have to go into 2 different places, make those changes. So doing it this way allows us to put everything in one place and then refer to it really cleanly. So what actually ends up happening is our final query is select merchant name. We want to look at the revenue. So that's that sum of revenue for each merchant. And then we want to divide it by another subquery, which is going to be select the sum of revenue, going to aggregate all those merchants from the sales table. So if we run that, we can do that for Nike buyers. So here we can see, Nike buyers, they're spending about 73% of their dollars just at Nike. So not a lot of leakage to other competitors. If we look at Lululemon, they're actually better. Almost 80% of their dollars just go to Lululemon. And if we were to do the same thing for Adidas, this is where we see a slightly different. They have a much lower loyalty than any of those other merchants, at around 65%. So by far, Adidas's buyers spread their spend around more than buyers from any other brand in this data set. So that's all we're going to cover today in terms of queries. We've got about 10 minutes or so for questions and answers. So I'd love to open it up to anybody who has a question. Yep, down the back there.
The date conversion that you did earlier,
Mm-hmm.
was that the select statement?
Yes, so the question was the date conversion that we did earlier, whether it was in the select statement. So you can use a date conversion in a select statement. You can use it in a where statement. Anywhere that you want to use a field, you can actually use any of those converters. So you can use it in a bunch of different places. Yep.
So why do you use pop SQL as opposed to other SQLs?
It's a good question. I use pop SQL myself because we use at Aggregating Intelligence a platform called Snowflake. It's a cloud database service similar to AWS. And there's very few kind of client, OS X native apps that connect to Snowflake. So that's why I use PopSQL. I also really just like the interface. It's really handy to be able to look at charts within the editor itself, rather than having to either put it into a BI tool or chuck it into Excel or do something to get those pretty simple trends. Yeah, down the back there. Yep.
When you said that you could see a trend that could have any
Mm-hmm.
number of causes, and then you listed 5 or 6 of them,
Mm-hmm.
and we dug into one, but when you're doing this in a real-life scenario, would you investigate all possible causes before you become satisfied?
Yeah, absolutely. So, when we're doing projects with our clients, we will, we'll dig into a whole bunch of different reasons to make sure that we can kind of adequately explain to them what's going on, with a trend or, within a data point that we see. Yeah, over here.
So, like with, like in the field of sport, like
Mm-hmm.
with like knowledge of like other advanced tools like R,
Mm-hmm.
how do you think like R and SQL and maybe other tools that like Python that
Yep.
you're familiar with, like
Yeah, so the question is about other tools that you can use, so R, Python, and kind of how those compare with SQL. So frankly, I think they serve very different purposes. While you can do, basic analysis in SQL, if you really wanted to, you could run a, basic regression in SQL. It's not the most efficient tool to do that with. So that's where, things like R, things like Python are very powerful tools in terms of the different packages you can use. SQL, on the other hand, is great for, preparing the data. One of the biggest missteps I see, at least in, our company with, people who are kind of coming straight out of college is, they do have a tendency to dive straight into Python and just like pull an entire data set into pandas and then try and like work on it. It becomes really slow, really cumbersome. So I'd say they go hand in hand. It's more trying to, I guess, know when, which is the right tool to use at which point. So it really depends what you're trying to do. Yeah, over here.
When you're looking to hire data scientists and analysts, what sort of qualities do you look for and how do you test them?
Sure. So the question is in terms of hiring, what we look for for analysts and data scientists. Again, it depends on the role. For analysts on my team, we're looking really for two things. Now, we test for technical skills. So for us, that is SQL and Python. And then we also kind of test your kind of critical thinking skills, what you can actually do with the data set, how in-depth you can kind of analyze it. The way we do that is we'll actually use a data set like we have here and kind of run you through it, ask you questions, let's say we see that spike, bounce ideas around, hey, what do you think's going on here? How would you test for it? That kind of thing. So that's what we're really looking for because ultimately, what we're trying to do with our clients is answer their core business questions, so we need to make sure that, you can kind of logically think through a problem and come out with a solution at the end that kind of makes sense. Yeah, down the front here.
Do you use any MDX with Snowflake or?
We don't.
No business case for it, just like SQL rather than a multi-dimensional language?
Yeah, it depends. For a lot of what we do, SQL is enough. And then if not, we'll start moving into Python for certain projects. So. Yeah, in the middle here. Yeah. Customer lifetime value, I mean, that's a very hard thing to quantify. There's obviously a lot of techniques for doing it. So depending on the model you use, you could start to get to some of that in SQL. Ultimately though, nowadays you would probably be looking at, building a, lifetime value model in something like Python so that it can kind of run on top of your data set and kind of do it in real time. All right. So if anybody is more, interested in learning more SQL, there's a lot of great courses online. I would recommend, Udemy, Udacity, all those kind of online learning platforms. They're all free. There's great courses, and you can actually, start going there, learn some pretty complex stuff. So, appreciate all being here. If you like, feel free to email me, connect with me on LinkedIn, or if you are interested in what we do at Rakuten, feel free to visit our website, which is rakutenintelligence.com. So, thanks a lot.